Hello, I will now go through the shift compare instruction by showing the ASMD chart and how the microprogram memory for this instruction will be. First off, let's take a look at the ASMD chart. We start off by incrementing the RAM address. This is to start off at the next place in the RAM. Then later, iWord counter takes the value of the quotient and the rbit slash takes the value of the reminder. Then we can go down and check if the word counter is equal to 1 and the rbit slash is equal to 0, or the iWord counter is equal to 0. If this is true, then the btdi serializer will take the value of whatever is in the RAM. The same thing will occur both with the btdo serializer and with the mask serializer. All this will take the value of whatever is in the RAM. Then we will check if the rbit slash is equal to 0. If this is true, the cbits counter will take the value of the x. If not, the cbits counter will take the value of whatever was in the latch. And then we can go down here and check if the cbits counter is equal to 1. If the cbits counter is equal to 1, then we set the btms to 1 and we check if the error flag is 1. If the error flag is 1, this will show us an error. If the error flag isn't 1, then the btms will be 1 and the btck will be 1. Then we increment the RAM address and load the bank reg and reset the ASMD state reg. The load bank reg is for loading up the new command that we want to work with. And the reset ASMD state reg is to reset the ASMD chart so we can start off at the next command. If the cbits counter wasn't 1 here, then we would set the btck to 1 and decrement the cbits counter. We would also serialize all the 3 serializers and check if the error flag is 1. If the error flag is 1, we will get the error. If not, we will go back into the and check if the cbits counter is equal to 1. Then we'll do the same process again. Then we can go up here and check what will happen if the word counter isn't equal to 1 and the rbit slash isn't equal to 0 or the iWord counter isn't equal to 0. Then we will end up here. Then we will have to put the value of x into the cbits counter and take the value of the RAM content into the btdi serializer. We will also have to take the RAM content into the btdo serializer and into the mask serializer. We have to check if the cbits counter is equal to 0. If the cbits counter is equal to 0, we will check if there is an error flag. If the error flag is equal to 1, then we will get an error. If the error flag isn't equal to 1, we will decrement the iWord counter and go all the way up here to box 2. Then we will do this process that I explained earlier. If the cbits counter here isn't equal to 0, we will set the btck to 1, decrement the cbits counter, and serialize all the 3 serializers. Then we will also check if the error flag is equal to 1. If the error flag is equal to 1, we will just get an error. If not, we will go all the way up to box 17 and do this process again. If we get this error, we go down here and increment RAM address, load bank reg and reset ASMD state reg. This is to end this command and start off at the next one. And this is very basic how the ASMD should be for this instruction. This will just be a very basic overview of the microprogram memory for the instruction shift compare. We can see that in the ASMD state 0, as I explained, we increment the RAM and we don't have to set anything to 1 because nothing is changed in the data path. If you look back to the ASMD chart, you can see that in the ASMD state 1, it will just continue. And as I mentioned, we will set the iWord counter and the rbit slash to the quotient and the reminder, so we have to set both these at 1 because they will change after this ASMD state. In the ASMD state 2, we had our true or false node. So we just declare this here by saying bif of the type D, and we can see that nothing changed in the data path in this state, so nothing will be set to 1.